Hi everyone, today we are going to talk about how to get the normalized difference vegetation index, or in other words we call it just NDVI, which is a vegetation condition whether it is healthy or stressed. First of all, let's begin by learning the definition of the index. Usually the normalized difference vegetation index is a numerical indicator that uses the near-infrared and visible red bands of the electromagnetic spectrum. The basic formula for the NDVI is as the following. So to get the NDVI, we need to subtract red light band from near-infrared, and by dividing the sum of near-infrared and red band. For Landsat 8 satellite images, we need to use bands 5 and 4, and for Landsat 4, 5 and 7 satellite images we need to use bands 4 and 7. So to get NDVI we need to go to adding data button, and by clicking the button we need to add bands 5 and 4 of the Landsat 8 image if you have downloaded that version. So 4 and 5, and click add button. And after getting them on the table of contents, we need to go to Arc Toolbox, then Special Analysis Tools, which are used to work on raster data. Then we need to go to Map Algebra, then Raster Calculator, to work on the formula of the NDVI. So once it opens, we need to go to float, this one, and by clicking it in the brackets we need to put band 5 and subtract band 4, then divide, and then again float, and then in the brackets band 5 plus band 4. And here you can rename the output image and you can show your save location. After that you can press OK, and you will be waiting some time to get the results. So after getting the output image like this, ranging from -0.3 to 0.6, we need to get acquainted with this information. NDVI usually ranges from -1 to 1. If you have negative values from -1 up to 0, then it's highly likely to be water body. In contrast, when you have positive NDVI values close to 1, there is a high possible availability of dense vegetation. However, if the value is close to 0, it would mean that there are not green leaves in the place and it could be an urbanized area. Also, values which are close to 0 to 0.15 correspond to bare soil. That means there are not any green leaves. The values ranging from 0 to 0.3 account for shrubs, and from 0.3 to 1 correspond to healthy vegetation, or in other words we call it densely vegetation. So now we are going to use this information in the symbology tab of this output dataset by going to Properties, Function, a table will be shown here. Just it takes some time. And we need to go to Symbology tab and then classify it, because we are going to classify our output. And here classes should be 4, and we are putting 4 here. And to put our ranges provided in the table, this information, we need to press classify function, and in the break values we need to put our values. So here 0, here 0.15, and here 0.3, and here 1. So press OK. Then we need to name this as classes here: water body, bare soil, shrubs, healthy vegetation. And also we have to change the names of the colors of the images here. For example, here we're putting this, and water, we know that should be in blue color, and bare soil kind of yellow, and shrubs can be in pale green color. And for healthy vegetation or dense vegetation, you can choose a leaf green, and then apply, then OK. So here is our output NDVI. So we can rename the name of the output image, writing NDVI. You can also get NDVI by using Windows and image analysis, and then you need to select bands 5 and 4, and then go to NDVI, and NDVI will be calculated automatically by pressing it and waiting for some time. You can get the image. The classes of 4, and choosing right colors for each classes, you can get the second NDVI in another method. So you can see the output image. And the second one is the same as the first one. So now you have now 2 ways to get NDVI, which are very useful for future research and for other projects. Thanks for watching.